I always do that. So for this one, B as it reaches, what was the velocity that we got of ball A? Wasn't it like 2.6 meters per second? Okay, so the velocity of ball A is 2.6 meters per second. If ball A is moving, so that's VA, and then VA final is 0.15 meters per second after the collision. So what is the velocity of ball B? So how do we start every momentum problem? PI equals PF. And then what's moving before the collision? Just ball A. So we say MAVA. Because do you see ball B is not moving? Is everybody okay with that? Okay. What's moving after the collision? Ball A, because I've given you a VA final. And remember, we're supposed to find VB final. So it's ball V as well. Ball V. Ball B. Jeez. Okay, so solve for VBF. That's it. So we get MB VBF equals MA VA minus MA VA final. Divide both sides by MB. And calculate your answer. And of course, the thing that we can do, right, is since the balls have the same mass, what can you do? Click, 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 and so you get VA minus VAF, which gives you 2.45 meters per second. Now, if ball A and ball B stick together, what is the velocity of them stuck together and how much energy is lost? So, once again, how do I start every momentum problem? PI equals PF. What's moving before? Yes, only A, MAVA. What's moving after? Both, MA plus MB, and since they're stuck together, I have V. Right? I could write it like this. MAVA equals MA times V plus MB times V. That A is annoying. Ah, there we go. Do you see that those two are the same thing? Right? Because if they're stuck together, V has to be the same, right? So that's just for declarative purposes. So here I can just say V is MA VA over MA plus MB. Well, that's the same thing as MA VA over 2M. And I can cancel that. So I get VA over 2. So there, V equals 1.3 meters per second.
It turns to 2M because they won't.
Yeah. Now, now I have to. How do you find delta V? Hmm? Okay, final minus initial. How do you find delta anything? Final minus initial. So, I'm going to do KE final minus KE initial. Now, the final. What is true about the final? They're stuck together. Remember? The two balls stuck together. So here, I'm going to put 1/2, and then I'm going to say 2M. Does that make sense to you?
No.
Right? They're stuck together. 2M. And then I'm going to say V squared minus. Now, what was moving before the collision? Just A. So I can do 1/2 M VA squared. Does this make sense to you? Questions? Questions? The 1/2 what? I'm sorry? Oh, okay. You see we're just finding the kinetic energy before and after the collision. After the collision, they're stuck together, right? So what's the mass? It's twice as big because they're the same mass. So the mass is 2M. So we have 1/2 times the 2M mass times the velocity that they have when they're stuck together. We figured that out above, and I just called it V up here. So up here I called it V. So what I get here is this becomes the mass, which is 0.185 times 1.3 squared minus 1/2 times 0.185 times 2.6 squared.
That one. Oh, okay. Cancel out the 2.
Yeah. So, yeah. Yes, the first one did. The second one, there is no 2. But yes, you're right. That's why there's no 1/2 down there by the 0.185. So multiply that together. Tell me what you get, please.
Yeah.
So plug it into your calculator and get an answer, please. Yes. What? Okay. All the m's are the same. MA equals MB, so you just cancel. Anybody get a number?
Negative 0.3.
Negative 0.3? 31 joules.